Hello viewers, welcome back to the course on scientific computing using Matlab. So, in the previous lecture we have discussed the error estimates involved in the interpolating polynomial. So, today we will continue with that, and today we will start with the Newton backward difference method. So, today I will discuss with the Newton's backward formula. Backward difference formula, or I should call it that is BD, backward difference. So, in this case the same as we have done the Newton forward. So, I have my x, that is x naught plus ph. I have the points, this is x0, x1 up to xn. So, this n plus 1 points are given to me, and I want to choose any x that is lying in between somewhere. So, I choose x is equal to x naught plus ph, where my p can be written as x minus x naught by h, and where h I know that is xi minus 1, and this is constant. So, this is all are equispaced. So, in this case I want to find the value of the function at fx, or I can want to find what is the value of yx. So, this one I can represent as yp, because x is involved with the parameter p. So, this can be written as ep and then y naught, and from here I know that this can be written as 1 minus nebula minus p y naught. So, that we already know, because we know that the relation between the shift operator E and the backward operator is 1 minus nebula inverse. So, I use this one. Now, I apply the binomial expansion. So, it will be 1 plus p del. So, this y naught I can write after that. So, this can be written as this, then p p plus 1 by 2 factorial square, then this p plus 1 p plus 2 by 3 factorial, and so on. This is equal to y naught. So, I know that this infinite series will terminate whenever we reached at the higher order operator. So, from here I can write, now I can write that my yp will be, this is y naught plus p backward operator y naught plus p plus 1 by 2 factorial y naught, and so on. So, that is my Newton backward difference formula. Now, from here I know that what will be the nebula y naught. So, it will be y naught minus y minus 1 square y naught. So, this will be y naught. So, I can from here I can write 2 times I have to apply. So, I will apply it this like this one. So, this will be y naught minus minus 1. So, that is y naught minus y minus 1, and from here this is y naught minus y minus 1 minus this is y minus 1 minus y minus 2. So, it is y naught minus 2 times y minus 1 plus y minus 2. So, the 3 points are involved in the second backward difference operator. So, from here I can say that in this case I am going backward using the Newton backward difference method. So, let us do examples, then it will be more clear to me, and also in this case the value of the p should be between 0 and 1. only then I can apply the Newton backward formula. So, let us do one example based on this, or I can say from here that this value p between minus 1 and 0, so this value should be there. So, let us take one example. I have the value, so this x is given to me 2, 2.5, 2.10, 10, 2.15, 2.20 and 2.25. So, at this value of x, my y is given to me. So, y coordinates are given to me, it is 0.69315, 0.71784, 0.74194, this is 0.76547, and this is 0.78846 and 0.81093. So, this 6 value is given to me. Now, the question is find or approximate the value, find the value y at x is equal to 2.07 and at x is equal to 2.21. So, these two values I want to approximate the value y at this 2x. So, let us do this one solution. So, now in this such type of questions, first of all I want to write the finite difference table. So, let's write finite difference table. So, this table first we have to make, this is my x. So, x is 2, 2.5, 2.10, 2.15, 2.20, 2.25. So, in this case you can say that my h will be 0.05 because this minus this, and these are equispaced, so no problem. Now, from here my y is given to me 69315, 784, because this is a large number of values are involved in there. So, it is more prone to write wrong values. So, we have to very careful writing these values. Now, I will apply the first difference. So, first difference will be, so this will be 0.02469, 0.02410, this value will be 2353, 2249, 2299, and this is 0.02247. So, this value is the first difference. Then we will go for the second difference. So, the second difference will be minus 0.00059, 0.00057, 0.00054, 52. Second difference, then we go for third difference. So, this will be 0.0002, this is 0.003, and this is 0.0002, so 40. point. Then I can go for fourth difference. So, this will be 1 and minus fifth difference will be minus 0.0002, and I know that fifth difference will be a finite with a constant, and the sixth difference will be 0. So, that is my finite difference table. Now, based on this one, first I want to find the value of this. So, now x is equal to 2.07. So, it is here lying. So, 2.07 lies here. So, in this case, so let we choose, let x naught is equal to 2, y naught is equal to corresponding 69315, and my x is 2.05. Now, from here I want to find the value p. So, I know that this x is equal to x naught plus ph. So, from here my p will be x minus x naught by h. Now, x is 2.07. So, it is 2.07 minus x naught is 2 divided by h, and h is 0.05. So, from here I can write that this is equal to 0.07 divided by 0.05. So, it is 7 by 5, it is 1.4. So, the value of the p is coming greater than 1, but p should be 0 and 1. So, in that case what we will do? So, let we choose x naught is equal to 2.05. So, let us choose this one. So, if once I choose this one, the value of p will be, in this case it will be 2.07 minus 2.05 divided by 0.05. It is 0.02 divided by 0.05. So, it is 2 by 5. So, that value is less than 1. So, in this case what we can do, I can write this as x naught, x1, x2, x3, x4, and this one as x minus 1. So, now I want to apply the, in this case I want to use the maximum value. So, we will apply Newton forward difference operator formula. So, for that, this is the value I am going to use, a y naught, this is the x naught and this is the y naught, and then I will use this value, then this value, and this value. So, in this case I will be able to use only 1, 2, 3, 4, 5 values. If x naught, if I choose the x naught is equal to 2, then I was going to use 6 values, but now I have to use only 5 values. So, let us do this one. We know that my yp, the formula is y naught plus p del y naught plus p minus 1 by 2 factorial del square y naught plus p minus 1 p minus 2 by 3 factorial y naught p minus 2 p minus 3 by 4 factorial So, I can go up to 4th only, the 4th difference. So, I will stop here. So, p, now I will substitute the values. So, my p will be in this case is 0.4. So, my p is 0.4. Now, from here the value yp means I want to find the value y at p is 0.4. So, my x approximate value is, I will substitute the value y naught. So, y naught is 0.71784 plus p is 0.4 multiplied by the next. So, it is 0.02410 multiplied by 0.4, 0.4 minus 1 by 2 factorial. So, the next difference will be minus 0.00057 plus 0.4, 0.4 minus 1 the next value will be 0.0003 and in the end I will get 0.4 the last value. So, it is coming negative. So, in this such type of question we have to take care about the calculation. So, from here if I calculate all this value using the computer or calculator, the value is coming. So, the value of yp is coming 0.72755. So, this is the value I am able to approximate using the Newton forward difference formula, and you can see that its value is 0.7275. So, it is 71784 and 74195. So, this value is lying in between here somewhere. So, from here I can see that this function is an increasing function. So, that is my approximated value. So, that is my answer. Now, the next case at x is equal to 2.21. So, in this case what I am going to have take 2.21 is lying here. Now, if I choose the 2.21 here and apply the Newton forward, so in that case it might happen that I will choose this as my x naught, and if I choose x naught, this will be my y naught, and this will be the first derivative, first finite difference y naught, and that is it. So, if I apply the same Newton forward to approximate the value 2.21, in this case I will using only two values, this and this. So, in that case the approximation will be not well defined, the approximation will be not good in this, we can say, because I am using only two values. So, in that case to find out the value at x is equal to 2.21, we should apply Newton backward difference formula. So, in the Newton backward difference formula, so in that case what I will do, let us take this one as green color. This one. So, if I apply backward, so I will use this value and I will call it x n. In the formula also I have used x 0. So, this y 0 is there, maybe I can call it x y n also, because I can take it as the last value, or some in some books this is also chosen as y0. So, if I choose this y0, then the previous value will be in the terms of x minus 1, x minus 2, x minus 3, or if I choose, so I will take this value, then the corresponding this value, then I will choose this value, again this value and this value. So, I am using these values because I know that in the forward I will go by this way downward, and the backward I will go in this way. So, I will go by this way. Okay. So, let us take x is equal to the last value 2.25 as xn, or in this case it is x6, that is equal to x6. I can also choose this. So, if I choose as a x6, then the previous value will be x5, x4, x3, or if we choose x is equal to 2.25 as x0, then the previous value will be represented accordingly. Okay, so I can call them y0 or yn, does not matter. So, let us apply this formula. So, in this case I know that Newton backward difference formula is yp is equal to, so I call it 0, 1, 2, 3, 4, 5. So, it is, in fact it is 5, it is x5. So, I can write as a f y5 plus p backward y5 plus p plus 1 by 2 factorial y5 p plus 2, p plus 3 by 4 factorial and the fourth y5, because I can move up to fourth order only. This value, no, this value is not this value, just I have to make little change here, because I am choosing this value. So, the value will be this one now. So, this is my x0. So, this is my x5 and this will be my y5. So, this is the y5, then this value, then this value, then this value, then this value, and then this value. So, in this case I am using in fact 6 values. So, this I am using the maximum value I can use 1, 2, 3, 4, 5, 6, because this is the y5. So, in this case I have to go one term more. So, that will be p 5 factorial and then the fifth difference. Now, if I substitute the corresponding value, so first of all I want to find what is my p. So, in this case my P will be x minus x naught by h. Now, my x is 2.21 minus x naught we have chosen. So, x naught is basically the last value I have chosen, because we have represented this one. So, I told you that this can be x naught also. Okay. So, x naught is same as x n, the last value. So, this will be 2.25. So, that should be clear that what is the meaning of x naught here, the last value, and h is 0.05. So, in that case this is the minus 0.0504 divided by 0.05. So, this is minus 4 by 5. So, in this case the h is coming, so minus it is 0.8. So, this value is coming, and I know that our value P should be between minus 1 and 0. So, that should be there. So, it is qualifying for this one. Now, from here I can write my y at x is equal to 2.21. So, this is equal to y at this point P. So, this P is whatever the P is there. I will substitute all these values in the given formula. So, this is my formula. I will substitute all these values. So, I will start from yp 0.81093, 0.8109093 plus P is minus 0.8, and the first difference is this one 0.02247, and so on. So, I can substitute all this value, and then using the calculator we can find out this value, and this value is coming 0.79300. So, that is my approximate value of this one. So, I call it y is equal to 2.21, that is equal to 0.79300. So, that is my approximate value. I cannot write this as, we cannot write this as y is equal to 2.21, because this it means that I know the value of the function and substitute the value there. So, this is the exact value. Okay. So, an exact value I can find only if I know the value of y. So, that is my approximated value, and this is my answer. So, from here I can say that whenever the value is to be found out that lies in the upper part of the table, I will go for the Newton forward difference, and when this value lies in the bottom of the table, then I will apply the Newton backward formula. So, in the next lecture we will see that if the value lies in between some values in the middle of the table, then we can apply the central difference formulas. So, that is all about this Newton backward and Newton forward. So, I should stop here. So, today we have discussed about the Newton backward difference formula, and we have also tried to solve one example and to approximate the values that is lies in the upper part of the finite difference table and the lower part of the finite difference table. So, that is all about today. In the next lecture we will go further. So, thanks for watching. Thanks very much.